set the work up, or the odor research up from a bigger picture perspective. So, why do we study air pollution and climate change? Today we know we have these plethora of let me turn on my yes. So we have a plethora of anthropogenic and biogenic sources, which then produce multiple reactive chemical species, such as reactive organic carbon, which then further react in the atmosphere and form secondary PM, so secondary particles, as well as tropospheric ozone and secondary carbon dioxide as well. And we know that these precursor chemicals and their secondary products have a substantial impact on human health, including large-scale impacts on mortality, morbidity, as well as impacts on ecosystems and biodiversity. So, if we want to make a dent in global health, reduction of these air pollutants is a surefire way to make that happen. And that's where sort of the current study comes in. So in this study, I focus on odor sources. There's a lot of them, which then produce organic and inorganic compounds, but also form secondary products, such as secondary aerosols, as well as contribute to issues related to tropospheric ozone, which is particularly relevant for the Metro Vancouver region as well. I also want to note here that in the list of sources on the left-hand side, I have included some sources such as agricultural burning or residential burning and wildfires, even though they are traditionally not considered odor sources or not regulated in odor management, but it is well known that they do produce odor or odorous compounds. So odors are a special category of air pollutants in the sense that they are very visible. In contrast, pollutants such as fine particles in air, they're not exactly visible, but odors are. And we know this because if you look at the different categories of odor or air pollution complaints that regulatory or monitoring agencies receive, a large majority of them are odor complaints. So we're very acutely aware of odor issues around us. And I'm not surprised. Odors are powerful agents that can tap into our memory, affecting cognition and mood. They can contain irritants and toxic constituents. And as I showed before, they produce fine particles that can go deep inside our body and cause multiple diseases. Okay. And odors can affect economic livelihoods as well. Houses and commercial properties that are nearer odor sources often lose their property value. And this is something that we actually seen reported in our project as well. And despite all these different aspects through which odors affect our lives, it is typically only considered an annoyance or a nuisance at best. There's also, even though odors are caused from chemicals, there's also a subjectivity to it, the pleasant skunk. And what I mean by that is there are people who would actually find the smell of a skunk pleasant. And it is this subjectivity that's sort of mediated by our sense of olfaction. And this brings me to the question, to the second poll question: how often are you exposed to malodors in your daily life? Is it very rare? Is it rare? Is it moderate? Is it frequent or very frequent? It's interesting. So there's a large category of responses on the. So I would say if I sum them up, there's about 55% of the audience which has experienced moderate, about one time a week, to very, very frequent odor experiences, which sort of gives you an idea that some of us can experience a lot of odor issues in our lives. And you'll be surprised to know that the state of the science when it comes to odor detection and reporting of odor impacts is actually the human nose. It's not an instrument. Clearly, our nose knows a lot. And it is this ability of human olfaction that we utilize in our crowdsourcing project called Smell Vancouver. As a part of this project, community scientists report their demographics, their location, as well as the time of their odor experience, and also textual descriptions of the odors they experience, the symptoms they experience in response to those odors, the actions that they take to protect themselves, and finally, the suspected causes of odors. As you can see from some of these descriptions, people's experience of odors and their descriptions of them are extremely rich and evocative. And so since this was sort of the first study that was being conducted as a part of the Smell Vancouver project, we wanted to address some fundamental questions. And these include methodological questions on what are the strengths and limitations of the crowdsourced science approach for characterizing a region's smellscape. What are the patterns of odor? So we study spatial, temporal, and textual patterns of odor. And we also think about what explains some of these odor patterns. What are the potential drivers or influences of these odor patterns? And to do this, we've conducted analysis on many different fronts that I'll today conclude with sort of a policy instrument or policy metrics that we've constructed based on this analysis. We've taken 1 year of data, which has about 550 reports, which is actually pretty large for a community science study. And we've been continuously collecting data, which now has about 1,300 plus reports. So there's almost a 20% year-on-year increase in odor reporting to our app. We've conducted textual analysis of the open text data that I showed before, where people can describe their odor experience, and that involved coding of open text to different odor, symptom, action, cause categories, quantifying the relationships of those categories with each other. So those are sort of binary relationships. And you can do this using a metric phi, which is a Pearson-like coefficient. We've also conducted spatial analysis of odor report counts. This included identifying odor hotspots and outliers in the region, as well as temporal analysis, which included conducting monthly multilinear regression and then sort of averaging out and seeing what the different contributors are. Finally, we also conducted comparison of app demographics to the Metro Vancouver demographics to see how representative are community science studies, Smell Vancouver in particular. And at this point, I just want to get an idea of what are the symptoms you've experienced, right after you experienced an odor. What are the symptoms you associate with some of the odor experiences you've had? So this one has a lot of options. Okay, there's a lot of emotion and mood disturbance. You also see headache, a lack of appetite or nausea. Those are some that I've experienced. Right. Yeah. So every symptom that I sort of gave as an option, someone has reported it, and that sort of gives you an idea of how diverse our experience can be of these different odor experiences. And that's kind of what we see in our data as well. We see a wide diversity of symptoms in our data, including neurological symptoms, respiratory symptoms, ophthalmological and dermatological symptoms, such as hives, but also a wide range of emotional and mood disturbance. You name a negative emotion, sadness, fear and confusion, anger and disgust, we saw them all. But interestingly, we also saw a lot of maladaptive actions being reported, where our crowd scientists were forced to choose amongst environmental stressors. They were forced to choose the risks they were getting exposed to. And to just give you some examples of that, they could choose getting exposed to odors or heat stress, odor exposure or risk of getting into accidents, and then odor exposure or the risk of getting exposed to particle pollution. And that sort of gives you an idea that odor is probably not just an annoyance, but has this complexity of health impacts that cannot be easily captured, or that needs further study. And to better study these odor-mediated health effects, we sort of took our descriptions, mapped them into word clouds, categorized them into different big categories of odor, symptoms, actions, and causes, but then linked them using the textual correlation coefficient phi. And we then plotted the most common binary relationships on constellation-based smellscapes such as these. So the figure that you're seeing is sort of representative of an annual smellscape of Vancouver. Let me go over the legend because it's sort of complicated. The different nodes or circles represent the different types of odor experiences or different components of the odor experience. So odor, symptoms, actions, and causes. The line segment that connects them, the thickness of that is represented by, represents the correlation magnitude, and the color of those line segments represents the direction. Is the correlation positive? Is the correlation negative? And so what you can see is we see a bunch of intuitive and non-intuitive connections. And let me go over some of the intuitive connections that you expect to see in a plot like this. So the cause of restaurants and food cooking is linked to the odor of food. That's sort of intuitive. Similarly, chemical causes are linked to chemical odors. Fire, smoke, and burning is linked to burning odors. But we see some non-intuitive connections as well that we think give us some insight into odor-mediated health impacts. And let me go over a couple of those. So the cause of garbage and compost is linked to the odor rotten, but then the cause garbage and compost is also directly linked to the symptom neurological. On the other hand, if you look at sort of this trajectory or this linkage, the cause of fire, smokes, and burning is linked to burning odor, which then is linked to respiratory irritation. The cause of fire, smoke, and burning is not directly linked to respiratory irritation, but only through this reporting of odor. And it is sort of the contrast between these two types of linkages that we feel kind of suggest or provide preliminary evidence of odor-mediated health impacts. We see linkages such as one, where the cause is directly linked to symptoms, which we think is more representative of the effect of the cause. But we also see linkages which are mediated by the odor, which we believe are more representative of the impact of odor. And before I begin, sort of move on to the spatiotemporal analysis of odor report counts, I'm wondering what are the regions in Vancouver where you have experienced odors, where you think odor hotspots exist? And I'm really curious to see what you say. Delta is really catching up to Vancouver. Surrey is a big surprise to me. All right, so we see Vancouver sort of wins it, I guess, or a lot of odor is being reported in Vancouver. Then there's Delta, and then there's actually Surrey and Richmond. So we see a lot of these. These spatial patterns in our data as well. The figure here is showing you different hotspots, cold spots, high outliers, and low outliers in Vancouver. And what you can see is that Vancouver, Richmond, Delta, and Burnaby account for most of the hotspots that you see in the Metro Vancouver region. The region around Surrey and the other suburban regions, they mostly are a cold spot, but there are a few places in different parts of those regions where there are high outliers or isolated locations where we see a lot of odor reports. But mostly we see odors where their sources are. And to just give you an example, for example, there's a high density of industrial units near the inlet in the northeast of Vancouver, as well as in Burnaby. And we see odor hotspots there. Whereas in Delta, it's very well known for its perennial issues with waste management. And we see a lot of composting reports from that region. We've also looked at odor reporting in terms of different days and what's happening. And we see actually that odor reporting in Vancouver is associated with a lot of events. And these include the launch of the app, but also two odor cause pairs that keep on repeating again and again. The first odor cause pair is chemical causes and odors, but the second actually is rotten odors from composting and animal rendering. But what's most interesting about the temporal story is that we receive most of the reports in the early morning hours of the summer months. So this is somewhere between 2 a.m. and 8 a.m., which I would say is an unusual time to see a lot of odor reports. And we hypothesize some of these causes that are behind this temporal pattern. It could be that there's diurnal cycle of emission releases, which is associated with the operating schedules of different industrial facilities. And so that's what's being represented here. But it could also be associated with the meteorological phenomena. So for example, Vancouver is a coastal area. It experiences fumigation, where plumes get trapped close to the surface, leading to high concentrations. Also, the feeling of annoyance is probably going to be higher in these hours because of disruption of sleep. And while odors typically do not disrupt sleep, odors can be caused by trigeminal chemicals, which cause pain and irritation in the trigeminal nerve. And hydrogen sulfide is a good example of such a chemical. We then conducted monthly multilinear regression of odor report counts and connected it to a variety of air quality and meteorological variables to see if some of the hypotheses that we've identified are backed with some of these correlations. And indeed they are. About 60% of the variance explained in these regressions is explained by a wide variety of ventilation and air pollutants. It sort of represent our hypothesis. Of course, this requires a further study using dispersion modeling to comprehensively establish that linkage. And lastly, before I sort of move on to the policy metric side of things, we also conducted a comparison of demographics from our app users and then compare it to the demographics of the region. We can do this because we actually receive demographic data in most of our reports. And we see that the two largest groups that report to the app are not likely from vulnerable populations. We also see biases in terms of age, in terms of gender and minority status, which suggests that our app is actually not representative of the region as a whole. I would love to hear your suggestions on how we can improve on this in the Q&A section. But I would still say that in the course of this project, we've developed a new odor monitoring approach that can account for behavioral response. We call this approach STOSAC, or spatiotemporal odor symptom action causes. There are traditional odor monitoring approaches such as FIDOL and CSOC, but I've mapped these traditional approaches to our approach. And what you can see is that while prior approaches capture the spatiotemporal variability and the odor characterization, they actually do not capture the behavioral experience in terms of symptoms, actions, and causes, which is what STOSAC is able to do. So hopefully this encourages you to use STOSAC in your policy planning as well. And to further help you with motivating, we actually went on and tried to think of some policy planning metrics that could be developed using the underlying qualitative data that we've collected. Till now, I've mostly discussed the spatiotemporal aspects of odor report counts, as well as some textual analysis. And the spatiotemporal analysis that I've presented only partially tells you about the intensity of odor impacts in different regions, sort of in terms of the odor report count, and only partially tells you how similar or different the odor impacts are again, based on odor report count. But what we can do with our data set is apply a vector-based representation to it. And let me go over this slowly to demonstrate its value. So imagine if users could report odors in only 3 categories. Let's start with burning. They can also select rotten, and they can select chemical. In that case, I can sort of create this vector space, which is a 3-dimensional space, and people can report odors somewhere in this space. For example, 1, 0 in this space would be a strength of 1 along the x-axis, a strength of 1 along the y-axis, and a strength of 0 along the z-axis. So sort of this point. And so similarly, you can represent each odor report in this space. So why are we even doing this, right? There's a huge advantage to using the vector-based approach. One, it can allow you to quantify the intensity of odors, and that would be the length of your vector. And it can also allow you to quantify similarity of odors, which would be the direction of vector. To create indices that can be used for policy planning, we normalize these metrics. Let me first talk about the intensity-based index. We believe this index, which we're calling II, can monitor chronic and acute incidents. As I mentioned before, this metric is based on the length of vectors, and it would be calculated separately for odor, symptom, and action. And then to calculate the total intensity of each report, you would just sum those up. So it's sort of an additive metric. We've also done analysis for geometric metrics, and we see similar results. You can then quantify the intensity of experience in each tract by summing all total intensity indices, which we believe is a measure of chronic incidence, or averaging it, because an average sort of gives you a metric of what is the experience a report, even a single report could be. And so it's sort of a better measure of acute intensity. Overall, higher values of this index would imply a higher intensity. The figure on the left is showing you the cumulative OSAC intensity score by different tracks. The figure on the right is showing you the average OSAC intensity score. The legend, if you see, they have the same number of breaks, but they are scaled differently. On the right-hand side, what you can notice is that the values go between 0 and 3, and that's because in case of the additive index, we are summing the index for odor, for symptom, and for actions. So each of them goes from 0 to 1, and that's why it's scaled 0 to 3. What you can see on the left is there are very few regions that are reporting really, really high number of odor reports cumulatively, or reporting odors of a high intensity cumulatively. And sort of these are the regions which have a persistence or chronic incidence. And so these regions would sort of be prioritized for that aspect. But also, if you look on the right-hand side, you see a huge contrast. You see many regions which have a very low frequency on the left, but are really high on the average OSAC intensity score. And so a comparison of these two figures actually points out that there are tracks in Vancouver where there are not a lot of reports being reported to Smell Vancouver, but even those few reports are of very high intensity. And so this sort of plot tells you about the acute experiences that people may be having in terms of odors. And so, where could you use this intensity index? First, you could identify chronic regions or subregions in a city, areas with persistent presence. And so, some of these would be environmental justice communities. You can also link odors to health outcomes now that we have this quantitative metric, and evaluate interventions to address odors using trends in this intensity metric. Lastly, this metric could be used for urban planning. It could inform land use decisions, and ultimately create healthier urban environments. We also look at another metric, which is a cosine-based index for quantifying similarity. As I pointed out to you before, direction of a vector can be used to identify similarity with other vectors by comparing their directions. This is a cosine-based approach. And again, it needs to be estimated separately for odor, symptoms, actions, and causes in our OSAC approach. This is an average metric. It does not have a cumulative score, and it ultimately quantifies the similarity of reporting in a tract with every other tract. Higher values of the score imply higher similarity with the regional OSAC experience, taken one at a time. So, regional similarity in odor, regional similarity in symptoms experienced, a regional similarity with actions, and a regional similarity with the causes reported. And so we feel there's a clear story that we are able to capture with this index. The figure here plots the similarity index for possible causes reported by our crowd scientists for different tracks on this scale. Notice that now the scale is between 0 to 1 because we are reporting odor, symptoms, actions, and causes separately. And what you see is that most of the values are very, very low. And what that tells you is that people are reporting very dissimilar, disparate causes. And that's probably because you associate with the cause in your region. Like if you live in a specific region, you see around you and you report that cause. But as you move to odors, they're relatively more similar. And again, that makes sense. Odors don't follow geographical boundaries. They flow in air, they disperse, and are likely more similar. What was more interesting to us was that the symptoms reported by our crowd scientists were even more similar. And we believe what's happening here is that there are some common chemicals underlying different causes and odors, and those chemicals are driving these common symptoms. And finally, because odors are not very well studied, there is a dearth of symptom-specific actions that people take. And so they're sort of taking very similar actions irrespective of the odor they're experiencing. And that's why across the region, you see very similar actions irrespective of the diversity in odors or symptoms. In short, this similarity index allows us to summarize the diversity or lack of in the life cycle of odor experience in large spatial regions. Where could this similarity index be used? We believe this index could be used in emergency response. For example, if you start to see really high similarity within a tract or with neighboring tracts, it could be a marker for hazards such as chemical leaks. Once we've identified these areas with similar odor experiences, we can sort of pilot an intervention in a region and then compare changes in that region to other regions using the similarity metric. So it also assists in targeted odor management. And finally, and I think the most importantly, a similarity metric creates a shared sense of responsibility because it tells people we're experiencing similar odors. And it also probably will assist in increasing community engagement. To summarize, in this project, we've developed a new odor monitoring approach, STOSAC, that incorporates behavioral response in terms of symptoms, actions, and cause perception. We see a wide variety of symptoms and maladaptive actions being reported. This suggests that odors affect health, well-being, and quality of life. They're more than just a nuisance. And in particular, they are affecting healthy behaviors, coping skills, as well as our physical environment. We see evidence for odor-mediated health effects, which makes me believe that odors are not just an annoyance. We also see that odors don't have very clean signatures, but are associated with several ventilation and air pollutants. So they're complex markers of exposure. It's also important to note that odors are not monitored in traditional regulatory monitoring approaches. So odors could actually be capturing very short bursts of air pollution experiences that are just not captured in traditional monitoring approaches. And lastly, STOSAC also allows us to capture spatiotemporal variability, map smellscapes at a very low cost. And so using the data from this work, we can then develop tailored place-based approaches for odor management. We've also developed 2 policy-relevant metrics, one of which quantifies the intensity of the odor experience, and the other similarity of odor experiences. The intensity index hopefully identifies chronic and acute odor experiences, sort of that contrast. And so odor management should probably balance between those two, depending on the region, depending on the data that you collect. Whereas the similarity index summarizes the odor experience of a region in terms of its diversity or lack of very quickly. To end, I want to say this work would not be possible without you all, our crowd scientists. So continue reporting to Smell Vancouver, and hopefully we'll be able to present you analysis like this. Thank you so much.